The next section that you do is long division of polynomials. Very, very similar to the long division that you may have done in primary school. And I'm going to show you a couple of examples of doing long division that you did in primary school without the calculator. So I haven't seen these questions. The main thing for long division of integers or polynomials is make sure you've got very orderly working out and your columns become quite crucial in the working out. Looking at this question here, the first thing I'm going to do is try to make a bit of a rough estimate. So if I make this first number, I'm actually going to make the second number 25. 25 can go, I can do that easily into numbers, which means I'll make the first number with a 25 in it. 12,500 is close to 13,286. Therefore, 25 into 125 is, what, 5 times and 2 zeros. I'm hoping to get an answer close to 500. If I don't, I need to check my working out. So the point here is make sure you have a reasonable idea of what the answer should be. Alright, as I said, it should be set out very, very tidily. I'm doing this without a calculator. So 26 into, I think I'm going to need more space. So I'm going to do it over on this side. So 26 into 1, 3, 2, 8, 6. 26 into 1 doesn't go. So you carry the 1. 26 into 13 doesn't go. So I carry the 13. 26 into 32, I'm going to make a guess here. 25 into 100 is 4. 25 into 125 is 5. Let me try 25. You're doing rough working out. Don't go and get a scrap piece of paper. Do it on the paper in front of you. So what am I saying? I'm saying 26 times 5 is my guess. 5 times 6 is 30. 5 times 2 is 10 plus 3 is 130. So my answer here is 130. So it went 5 times, and 5 times 26 was 130. Now you subtract. So 2 times 0 is 2, and bring down the next number. 26 into 28 goes 1 time, so put it on the next column, and now 1 times 26 is 26. 28 minus 26 is 2. Bring down the next number. 26 into 26 goes 1 time. Multiply it, and I've got no remainder. So my answer to this question is 511, and I said it should be around 500. But keep your numbers in a very orderly column, so you might need to write a little bit bigger and space out your work a little bit. Let's do another long division without your calculator And I haven't seen the next question, so let's see how I go. Okay, as I said, I haven't seen this question. It's already organised for me. It might be a little bit small. I might need to write that out again. Let's have a look. Let's do a rough guess of it. That's 13's close to 12. I know my 12 times table. That looks like 2400. 12 goes into 24. That's why I've chosen 24. So 12 into 24 goes 2 times, and there's 2 zeros. So I'm expecting an answer around 200. Like I said, I'm going to set this out again. It's a little bit too squashy for me. So 13 into 2, 4, 7, 5. 13 into 2 does not go. 13 into 24 goes 1 time. 1 times 13 is 13. And now subtract. 4 minus 3 is 1. 2 minus 1 is 1. And bring down the next number. Now 13 into 117. We're going to say 10. No, that's 130. 9. No, let's go 8 or 7. I'll try. I'm going to go 7. So 13 times 7, 21. Carry the 2. 7, 91. No, I can go one more for sure. So 13 times 8 is 24. It's 104. Oh, and then there's 13. So is it 9 times? 13, and I thought that was going to be too big. 27, 2, 9, 11. There you go. 13 into 117 goes 9 times. 9 times 13 is 117. I just worked out. And there's 0 remainder. But I still have to bring this down. So 13 into 5 doesn't go, so it's 0. And I've got 5 remainder. So I've got 5 on what my denominator is, 13. So I had a remainder in this one. 190, I'm fairly happy with that because that is close to the 200. That was how you did long division. Let's have a look at polynomials. I've got lots of examples. Okay, division of polynomials, the process is exactly the same. When you look at what you're dividing into, that first polynomial, the leading digit, the leading power is a 3. So when you write it down in your working out, make sure the leading digits go down from the 3 and you haven't missed out on anything. So I do have all of them. I've got 3, 2, 1 and 0. Make sure you have got all of them, otherwise I'll have to include it. There will be an example with a missing one. Okay, so I do have all the powers. Now go ahead and work it out exactly like we did long division with numbers. How many times does the x, only the x bit, does x go into 4x cubed? It goes into it 4x squared. So put it on top of that column. 4x squared. Now multiply. So 4x squared times x is 4x cubed. 4 times 3 is plus 12x squared. Now subtract. 3 minus 12 is minus 9. So minus 9x squared. bring down the next number. So plus 2x. I didn't say 4x cubed minus 4x cubed is 0. All right, x into minus 9x squared is minus 9x. Multiply. Minus 9 times x is minus 9x squared. Minus 9 times 3 is minus 27x. And again, you always subtract. 2 minus negative 27, which is plus, which is 29x. Minus 9 minus negative 9, that will be a 0. Bring down the next number. Bring down that 7. This is why it's important to have lots of space. Bring that down. Bring that 7 down. So plus 7. X into 29x is plus 29. And multiply. 29 times x is 29x. 29 times 3. Oh, I'm doing this without a calculator. 29 times 3 is what? 27, carry the 2, 6, 8 is 87. And again, we're always subtracting. 7 minus 87 is minus 80. And that's my remainder. So I'm actually going to put here minus 80 on what you've divided by. So whereas in numbers you've got it beside it like a times, here it's actually a term. So it's minus 80 on x plus 3. Okay, the next one. First thing I check, I notice it's a cubic. Check, it's got all the powers. Cubed, squared, 1 and 0. So it has got all of them. Now I'll go ahead and start doing long division. I'm actually going to rewrite this because I'm finding the typing is too narrow for my writing. So I'm going to say x minus 2 into 3x cubed plus 7x squared minus 4x minus 6. X, you're only ever looking at that leading term. You're always dividing that into the next one. Okay, so x into 3x squared into 3x cubed is 3x squared. So put it on top of that squared column. Now multiply. 3x squared times x is 3x cubed minus 6x squared. Subtract. 7 minus negative 6 is 13x squared. Bring down the next term. Minus 4x. X into 13x squared is plus 13x. Now multiply. 13x times x is 13x squared minus 26x. And that is negative 4 plus 26 is 22x. Bring down, Vince, do you mind? Bring down the next number. Minus 6. X into 22x is minus 22. And multiply. Why did I say minus 22? That's just plus 22. So x into 22x is plus 22. Multiply 22x minus 44 and subtract. Negative 6 plus 44 is, what is that? 38. So this is, oh, and now I'm writing in red, is 38. So now I'm going to write this out again. There's a remainder of 38. So my answer is 3x squared plus 13x plus 22 plus 38 on x minus 2. Okay, another example. All right, got another division. They all seem to be cubics. Again, check. I've got cubed. I'm missing a squared. I'm going to stop there. So this is a good example to show you to fill all the columns. Therefore, like I said, I'm going to write this again because I just find this way too squashy. I've got x minus 1. How many times does x minus 1 go into? 2x cubed. My ticks have stopped. Therefore, plus 0x squared. Whatever's missing, still putting the working out. Then there's plus 4x plus 5. Go ahead and do exactly what I did before. X into 2x cubed is 2x squared. So you put it on top of that column. Now go ahead and multiply. Now subtract. That minus that, that's going to be a 2x squared. Bring down the next term. X into 2x squared is plus 2x. Now multiply 2x squared minus 2x. Now subtract. So I'm doing the same thing over and over again. 4 plus 2 is going to be 6x. Bring down the next number. So that's plus 5. X into 6x is plus 6. Multiply 6x minus 6 and subtract again. 5 plus 6 is 11. So I've got a remainder of 11. So again, to write it out, the answer is equal to 2x squared plus 2x plus 6 plus 11 on x minus 1. So the main thing is keeping everything orderly. I've got 2 more examples. I think I've got 2 more. It's 1 or 2 more examples. Okay, 2 more examples. This one here, it's still another cubic. Alright, I noticed that the powers decreased from the cubic, cube, squared, 1 and 0. So that's all okay. Now I'm going to do my long division. Follow the same process. I'm going to set it out so it's nicely spaced for me. X plus 1 into x cubed plus 5x squared minus 2x plus 1. X into x cubed goes x squared. Make sure you put it in the right column. Multiply x cubed plus x squared. Now subtract. 5 minus 1 is 4x squared. X cubed minus x cubed is 0. That should always be 0, but always check it. Bring the next one down. X into 4x squared is plus 4x. That times that is 4x squared plus 4x. Subtract. Always following the same process. Minus 2 minus 4 is minus 6x. Bring the next one down. X into minus 6x is minus 6. Multiply. Minus 6x minus 6. And subtract. 1 minus 6 is 7. And negative 6 plus 6 is 0. Always check it. Alright, so to write this out, my answer will be equal to x squared plus 4x minus 6 plus 7 on x plus 1. One more example. Let's hope it's not a cubic. Let's have a look at it. And yep, it's a cubic. Okay, this last one, there is the, let me just check this. There's the cube, the square, the 1, 0. Okay, they're all there. The only difference is this one is actually a 2x instead of an x. That could be anything. It could be x squared. But take each one as it comes. Okay, I'm going to set it out again. So this is 2x plus 1 into, make it nice and spaced out, 6x cubed plus 4x squared plus 5x plus 4. 2x into 6x squared. 2 into 6 is 3. And an x squared. Multiply 6x cubed. That first one should always be the same. Plus 3x squared. Subtract. 4 minus 3 is 1, so that's going to be an x squared. I've just made the 1 invisible. Bring the next one down. Plus 5x. 2x into x squared is going to be a half x. So, a half times 2 is 1, and x times x is x squared. A half times 1 is plus a half x, and now subtract. 5 minus a half is what? 4 1/2, which is 9 over 2. This is a little bit of a complicated one. Bring the next one down. Plus 4. Now, 2 into 9 on 2 is going to be 9 on 4. Now, 2 times 9 on 4 is 9 on 2x plus 9 on 4. Let's subtract. 4 minus 9 on 4 is what? Is times 16 is 7. 7 on 4. That's my remainder. So this is going to be, plus 7 on 4, 2x plus 1. That's my remainder part, the 7 on 4, and the denominator stays down the bottom. I had some fractions there. Make sure you check that working out. I'm just looking through it. It all looks okay. So that one was a little bit more complicated in that it had fractions in it. In all of these examples I had cubics. It's not necessarily so. You could have quartics. Always check the powers go down and just slowly divide, multiply, subtract, bring a number down. Divide, multiply, subtract, bring a number down. It's the same process over and over again. You're just working with different numbers. Good luck in that exercise.